Thank you very much for a kind introduction. Let me see. Okay, so today I'm going to talk about the Human Glycome Atlas project that's just started in Japan. And on behalf of the IG core and also the HGA project, I'm going to talk about this. And first of all, I want to introduce what is IG core. The IG core is a very local story because the government wants to try to merge the national university. Because the Gifu University and Nagoya University is geographically very close to each other, 30 minutes train. And and also the Gifu University is very strong in chemical carbohydrate chemistry. On the other hand, Nagoya is strong in their biology and medicine research. So therefore, we naturally merged together, and we decided to organize the new institution. This is the Institute for Glycocore Research, IG Core. And now we have a member of these guys, and the director is Kenji Kadomatsu, and vice director Chihiro Sato and Hiromune Ando. Under them, there are several researchers, including the foreign people, Jan, Rebecca, Morten, and Jennifer. And then we decided what should we go? So we have a lot of discussion, and we persuade the government to grant us some money to fulfill what we want to do. So that is the Human Glycome Atlas project. So this project is stemmed from the IG core. So what's glycans? This is needless to say to this audience, but what we do for the government or the public, we have done like this. So the human being, we have the 37 trillion cells. They are communicating with each other. And basically through the glycan layer this is the glycocalyx layer. So that is the glycans are very, very essential for the cell-to-cell communication. Therefore, the glycan is important. And also in the early stages of the glycobiology, so the Landsteiner demonstrated the glycans determine the blood type. So therefore, the glycan is very important, especially blood type incompatibility on the transfusion of a human being. So, and all living organisms have glycans, so including the viruses. Influenza virus, so many studies revealed the involvement of the glycans infection to our host cells. And during the pandemic, there are many interesting research, the SARS-CoV-2, and especially the spike protein that are full of covered by glycan chains. So therefore, there are many impressions from these interesting figures. And also we have the very important three persons in this glycoscience area. So, and this is a little bit older years, but recently, 2022, Karen Bertocci received a Nobel Prize after click chemistry. So therefore, we believe that more people come into this Nobel Prize in future, I think. And this is an aspect of the glycan-related drugs. This is according to the Nikkei Bio Survey, the 2023. So there are the top 3 drugs listed here. These are related to the glycan. and many other drugs will come after the research of many trials. And so, however, we have to stress about this point that glycans are difficult to study. The glycan structures are too complex to determine, unlike DNA or protein, because the mechanism of synthesis is a non-template driven one, so therefore no amplification methods are available, and they require direct detection. And also the glycan chain itself, they're very of high structural diversity. Therefore, the complicated situation are going on. However, we now enter an era in which these problems can be overcome, thanks to technological development, including mass spectrometry and informatics. So, using these logics, we persuaded the government to give us some money. So the government recognized the importance of the glycan chain, and our HGA project are now on the list of next project, promoted project. This is quite a large project the government promotes. And our vision of human glycan HGA is now the current status of the glycan information is very low, and these are the arrows here. But as compared to the genome and protein information, so we want to push up the levels up to the genome and protein levels. So this is our vision of the project. And this is the history of the infrastructure development. And as you know, the Human Genome Project started in the early 1990s, and they gave us the very fruitful consequences. And also the Human Protein Atlas that started in the 2000 and until now. So, however, as for the Glyco project, so far, until recently, in individual laboratory started the Glycome analysis. However, Japan, we started the large-scale academic frontier promotion project started last year, because we have a strong background of the glycobiology and glycosciences. So our project, HGA, is a 10 years project. So we set the two purposes. The one is the first 5 years and the latter 5 years. The first 5 years, we focus on the blood samples, and 20,000 samples are analyzed. And also we'll be focusing on the dementia and aged patients. And the latter half of the project, so not only blood, but also the other organs and tissues, and also the 200,000 samples targeted. And also our target disease also cancer or the diabetes mellitus, etc. So that means the expansion of the targets. And to attain this goal, so we have to have the high throughput equipment and the technologies. So therefore, we introduced the automation and robotics of the samples preparation, and also the informatics and the big data analysis are also improved. And after that, or during that ongoing project, so we try to edit the glycan structures by knowing the biosynthetic mechanism of glycans, and using that knowledge that we engineered glycans drafted. In more detail, so we have 3 goals all are related with infrastructure purposes. So one is the glycan information, and second one is equipment and technology, and the third one will be a collaboration. So first one is glycan information. So we have 4 segments. The segment 4 is a kind of goal of this is the database, the knowledge base, the TOSA will be constructed. By segment 1 to 3, products are installed in them. So in the segment 1, we try to in-depth qualitative data. This is the comprehensive glycoproteomics attained. And the second one, segment 2, and individual quantitative data. This is 20,000 to 200,000 samples collected and analyzed by the comprehensive glycoproteomics and also comprehensive glycomics, including the N-glycan or glycan, glycolipids, and free glycans, and glycosaminoglycans. And third one is the mechanism of the glycosylation. Glycosyltransferases are cataloged. All human glycosyltransferases are cataloged in the knowledge base TOSA. And also the glycan engineering and application will started. So here is a member of the organization, main member, I should say, of the organization of this HGA. So again, the project leader is Dr. Kenji Kadomatsu, and the segment leader are listed here. And so now in last year, 2023, this is the first year of our project. So therefore, this is the second year actually. And so far, so good. The progress is going. So of course, just 2 years. But I should stress that this is a goal 2, equipment and technology. This is an automation system, the robot of to prepare the glycoproteomics samples. Without this system, we cannot attain the 200,000 samples. So this is what we are now. And also, this is not yet ongoing. We have to consider about the industry academia co-creation. So we consider establishing this community consortium to utilize this TOSA. This is a database information. And also J-GlycoNet was established. J-GlycoNet is to connect the HGA to the researcher communities. Researcher communities not only in Japan, but also the international network. So therefore, J-GlycoNet is linked between the HGA and the research community. So again, this is, we have to say, here's the Nagoya University and Gifu University here, and we invite the Soka University, Galsic, and also the NINS, which is the National Institute, excels, and to 3 institutions that plan the HGA as well as this J-GlycoNet. Through the J-GlycoNet, we have the over Japan supporting system. This is the so-called collaborative fields. More than 100 researchers, Japanese researchers, supported our project. And in addition to this, we have the already international glycoscience network, and under Core to Core program, these guys on the photo already communicated with our HGA project, and we want to continue this relationship in future as well. And also, in addition to these guys and many other people probably in this audience, we are very eager to contact with you about how the Human Glycome project is contributed and from our side, Japan. Okay, thank you very much for your attention.
So thank you for the very nice presentation. Any questions from the audience?
Thank you very much. Yuri Elchenko, GSK. So for the 20,000 and then 200,000 samples you are collecting, what other information you're going to collect for these people? I mean, like electronic health records, genomes, what other things you think of measuring on the top of glycomes?
Yeah, you mean say it again, the last part is I can hear.
Yeah, what information other than glycan measurements are you going to collect for the samples? For the people?
Yeah, we have the connection with the cohort groups. Especially the first 5 years, we are focusing on the dementia and aging patients. Therefore, at least for Japanese, shown here, the facilities to have a cohort relationships. So we are given in samples as well as all other information about the patients. So these are all set together. Is it answer to your question?
Are you planning to measure genomes?
Yes, of course, yes. Especially the TOMO, this is already the large scale of the database, and they have all set, especially I don't know the term, but the chasing the same family and collect the genome. So this is very useful for us as well.
Thank you very much.
Welcome.
So maybe I can also add something to that. So this is something what we learned kind of in a heavy way, that we analyze a lot of cohorts where we own the glycan data, but we do not own any other data, including the age and sex. So if you want to share this type of information, it becomes difficult. So I think this is one of the topics for today. We have a brainstorming in the evening, where we will think about the ways we can get this data to be useful for reusing, to have it in some kind of a databases, because we do have 200,000 glycomes, but if somebody wants to get this data from us, we can give them glycomes, but more or less nothing else. We have only a couple of thousand people where we also have access to the clinical information. And this is the essential question, how to coordinate all these interests from the clinical people, from the cohort people, from us, and put at least something in the public domain so people can reuse it. Any other question?
Hi, I'm just wondering about the automation. Hi, I'm just interested in the automation setup you have there.
Yeah.
So how was it developed? Was it done as a custom service, or?
Yeah, currently, one of the researchers, Dr. Nakajima, in collaboration with some company, to make these robotics systems, and we applied. We use this machine to produce a lot of information, and if it goes well, so maybe we can open to the public. This is a kind of a necessity of our project is supported by the tax of the people.
Yeah, thanks for sharing the information on the Japanese plans. So, I mean, you go for really big numbers, and I'm just wondering which tissues you are targeting. So will it all be on blood, or will you also look into other tissues of the human?
Yeah, the first 5 years only for blood, the plasma and the serum in both. But the latter half, we continue this project, the blood project, but there we try to introduce the organs from the dead man.
Yeah, I just think that there's a whole part of the human body in terms of glycome which is uncharted and unexplored. So maybe that's also a challenge not only for you but for us here as a community, how we want to look into that. We are not only blood in terms of glycome.
I agree.
So obviously I think it's a great plan. I'm wondering, all of the data you already get is open to, the published. Maybe I missed some words mentioned by Dr. Gordon Rock, right? So are you going to open all of the data to the public?
Basically, yes. But we have to conquer before that the admission from the patient sample provided. This is a big issue for us. This is the private information. We can protect this information. So therefore, the opening, finally we wanted to open all the data to the public, but it's still time until that time, I think.
Okay, I understand. You mentioned you're going to do, let's say, 200,000 sample. Majorly it's in blood, tissue, organ. Now also you mentioned some diseases, right? So cancer is first. What are others? Maybe is your pay attention, you focus on.
Yeah, we have a lot of dreams, of course. So, but we decided to focus on the blood first. And after, this is 2 years after start. So we will see how it's going on. If this, it was successful, it is successful, so there we want to, dream it all explode, maybe.
Okay,
Sorry
thank
for
you,
that.
thank you.
Nelson Soares, MBRU Dubai. I'm just curious, what is unique about your cohort? What is the features that are unique when you compare with the other cohorts?
So all 4 cohorts is related with the dementia and also the aging patients. For example, the Alzheimer's disease and also the neural degeneration of disease like Parkinson's disease. This kind of all, I'm not familiar with that kind of thing, so sorry about that, but these famous disease are all
could you find the glycan specific or unique to this cohort? Could you, when you compare to others? That's the question.
Yeah, these facilities are focusing on the patient and the disease itself. They kindly collaborated with us.
Thank you.
Okay, thank you very much. I think we have to move on.